Hi guys, welcome to my YouTube channel. Today we'll be studying about structural modeling in Verilog. Structural modeling in Verilog is used to subdivide modules into submodules and further into more deeper submodules. So based on the hierarchy, the designer will have relative abstractions of the blocks, and if if the designer wishes to see the details of the abstraction, he may also go deeper into that hierarchy. So for our problem today, let's design a 4:1 multiplexer using 2:1 multiplexer. Okay, so 4:1 multiplexer is going to have four inputs, which is A3, A2, A1 and A0. A3 and A2 will go to 2:1 multiplexer. It will have a select line of S0. Next inputs A1 and A0 will go to a second multiplexer, and it will have select line S0 same. Let's name the first output as M1 out, as we'll use this as a wire in Verilog code. Second output is M2 out. Similarly, we'll use this as a wire in Verilog. Now both the wires shall be connected to a final multiplexer stage of 2:1 multiplexer, which will have select line S1 like this, and output will be Y. Similarly, if we want to subdivide 2:1 multiplexer into a tri-state buffer, we can do that. So what is a tri-state buffer? A tri-state buffer accepts input A, produces output Y based on select line S. So the truth table for tri-state table shall be like this: when S is 0, 1, output Y when S is 0 is high impedance Z, or also called as floating output. When S is 1, output is A. So we can design 2:1 multiplexer using tri-state buffer like this. Let's say first input is A1 and next input is A0. The A1 will go to the first tri-state buffer and select line will be S. A0 will go to the next tri-state buffer with select line S bar, and both outputs shall be joined together to give output of Y. This is nothing but equivalent to a 2:1 multiplexer. So this is how we designed 2:1 multiplexer using two tri-state buffer. One will have select line of S, and another will have select line